our own exercise on linked tables deals with installing different floor covers. And here, the first table we have lists the types of floor covers. These are laminate, linoleum, parquetry, and PVC. Now, across these different types we have different installment costs, which means that nevertheless we have a number of laminates. All of them have the installment cost per square meter of 120, and all the PVCs have the same installment cost as well. And then we have leftovers, which means that if we install the floor cover as we cut away some corners, some sides, there's on the average a 8% leftover rate for laminate and 6% rate for linoleum. This is our first table. Now the second table enlists all those floor covers. So in the first column we see the floor covers code. There is let's see how many. There is 11 laminates, for instance, so their codes are enlisted. And afterwards we have linoleums, and then parquetries, and then PVCs. And if we take one laminate, for instance this Lam 03, then the second column shows that it's on laminate. The third column shows the width of this particular floor cover. Here we see that this information is basically redundant. We are not going to be using it in our cost calculation, but it's in the table nevertheless. This is what often happens. I mean, we have some kind of an engineering or other aspects in the table as well. And we're going to be using this fourth column, which is the cost per a square meter. Now, the third table we have is regarding rooms. Rooms are at first numbered by room code, and we have a typical office setting where room 102 means the second room in the first floor, room 204 means the fourth room on the second floor, and so forth. So that's how they're numbered. Then we have information about the room's widths and lengths and heights, and then we have information about their areas. Well, this information can be straightforwardly calculated from the width and the length, but there is some information that cannot be calculated straight away. I mean, basically we would get we could calculate from width and length and height. We could get from width and length, we could get the boundary line around the room, and then if we use boundary line times height, then we would get the full area of all the walls and doors and windows all together. But how it is divided into doors, windows and walls, we don't know, so there is this information. Walls area is 44,4, doors area 2,5, and windows 3,5 for this first room. Now, again, a lot of redundant information. We will only be using the area and the rooms